In today's lesson, we're going to be learning about conjectures and counterexamples. Now, we've heard the word conjecture before, and we're going to dive a little bit deeper into it. A conjecture, again, is a guess, but it is a guess that is educated, so it's an educated guess, about something that is not obvious, something that is not obvious. A conjecture is a guess, but it's an educated guess about something that is not obvious. So an example of a conjecture, well, to show that, let's draw some things out. If I draw two triangles, I have one triangle like this, and some other triangle that's a little bit bigger, like this. Well, triangle A over here, I'll call it, and triangle B over here. I'm saying that these three sides are equal. That's what those hash marks are saying. Those three sides are equal. That's what those double hash marks are saying. Something that is not a conjecture would be to say these are both triangles. This is not a conjecture because it's not a guess, and even if you were guessing, it's something very, very obvious. These are definitely both triangles. Similarly, saying that these are polygons is not a conjecture. Not conjecture. Because these are very obvious statements. They're trivial. They're obviously true. A better conjecture about this would be to say, in triangles A and B, A and B, all angles are equal. Now, what that's saying, this is a conjecture that's saying that, all right, I'm guessing that every single angle in A and B are equal. Now, it's an educated guess because, well, these sides are equal, these sides are equal. Maybe they share some kind of property that says all of these angles are equal. Maybe that's true. We're not sure. But it's definitely not obvious. I can't just look at this and say that's definitely going to be true. I'm not really sure if these green hash marks here are going to be true or not. So this is an example of a good conjecture. Now, let's move on to what a counterexample is. We're moving on towards the end of this unit on talking about proofs. But before we get there, we need to see how to disprove something. And counterexamples are exactly how you do that. Counterexamples. Counterexamples. Now, a counterexample is an example that disproves a conjecture. Now, instead of trying to explain what that is, let's just show it. So, one conjecture that I have, and I'm going to take a moment to write this one out. Conjecture. A quadrilateral, or in other words, a fourgon, just a polygon with four sides, a quadrilateral with all sides of equal measure must have all angles of equal measure. So let's take a moment to read this conjecture again. A quadrilateral, or a fourgon, with all sides of equal measure must have all angles of equal measure too. Now I'm going to show you an example of a counterexample. A counterexample is something that's going to disprove this conjecture. Well, my conjecture is saying that all fourgons that have equal sides must also have equal measure of their angles. So let's see. If I draw a square out down here, well, a square is defined by every single side being equal, but then also a square is made of four lines that create four right angles. In this case, this is a fourgon, so that's following our conjecture. All sides are of equal measure, and it turns out that in this case, all of my angles are of equal measure too. So far, this looks okay. But if you've ever heard of what a rhombus is, well, that's just a square, and I'll try to draw these sides about the same, except instead you kind of push one of the sides over. Imagine you take a deck of cards, and you just have the same length, but I just push it over that side a little bit. Now, I have that the sides are all equal measure, equal length, but if you take a look, this angle right down here looks sort of like an acute angle. It's definitely smaller than this angle up here. Well, this is my counterexample. This conjecture must not be true because I just showed you one example where it's not true. And this conjecture is saying that for all quadrilaterals, if their sides are equal measure, that means that their angles are of equal measure too. That's what this conjecture is saying. That is this guess. And what I just did with a counterexample is I disproved that guess by just saying, hey, here's one case where that's not true, so that means that your guess is not always right. It can't always be right. That's exactly what a counterexample is, and that is it. Let's take a look at one other counterexample together. Maybe we'll do two. So I'm going to have another conjecture. Conjecture. My conjecture is that no quadrilateral is concave. All right, well, concave, we need to remember that means that it's with a cave, concave, concueva. And it's saying that no quadrilateral is concave. Well, for me to come up with a counterexample, I just need to show you a quadrilateral that is concave. So, if I can draw a four-sided shape, because a quadrilateral really just means a fourgon, if I can show you a four-sided shape that is concave, then I can disprove this conjecture, and then I would have come up with a counterexample. Well, let me try to draw one out. If I draw something that looks like an arrow, I have 1, 2, 3, 4 sides. Well, I just drew a fourgon, a quadrilateral, and this is concave because I have this part inside here. I've got a little cave in here. That means that this is my counterexample that disproves this conjecture. So this conjecture is false, and I just proved that to you by showing you a counterexample. How about something like this? Conjecture. I'll write again. No triangle is concave. All right, well, let's see if I can come up with a counterexample of that. If I try to draw a triangle, so I'll start the same way, 1, 2, well, it's not concave yet, it's not even a polygon yet. Well, the only other thing I can do here is just draw a straight line. This is not concave because there's no cave going inside of it. And I'm pretty sure that no matter how many ways I try to draw a triangle, even if I do really weird looking triangles, none of these have a cave inside. So as far as I can tell, I can't come up with a counterexample for this conjecture. Tomorrow we're going to be seeing a little bit closer, not quite, but throughout the rest of this week, the rest of this unit, we're going to be seeing how to prove a conjecture. Because right here we have a conjecture that I can't disprove. I can't come up with a counterexample for it. But I also, maybe someone could draw a really crazy triangle that only has 3 sides that is concave. So until then, we're not really too sure. We haven't proven it, but we think it's probably true because I can't disprove it. I can't come up with a counterexample.